So we're going to take a look at the unit test for moving straight ahead. I'm going to go through this fairly quickly, but please remember that you have the power to pause and replay anything that you need a second go around on. All right, number one. The tour operators thought it would be a good idea to get souvenir t-shirts for each customer who went on the ocean bike tour. They found a company that would sell them t-shirts with their logo for $6.95. Make a table and a graph to show the number of shirts and the cost. Okay. It doesn't specify how many shirts we need to go up to. So we're going to start by making a table. So we want the number of shirts, S is for shirts, and the cost. And you're always going to have to start at 0. Because we need to find something called the y-intercept, which will be helpful later when we try to find equations. So the cost of 0 shirts is $0, right? The cost, let's go by ones, let's just make life easier. Cost of 1 shirt is $6.95. The cost of 2 is going to be $13.90. Cost of 3 shirts is going to be $20.85. 4 shirts is going to be just a little bit more than that. So we have, just going to double check my math. So we have $6.95 plus $6.95 plus $6.95 plus $6.95 and so I'm going to stop after 5 shirts plus $6.95. Now, would it have been appropriate to count by, say, tens? Yeah, that may make sense too, but it doesn't specify. So in this case, I'm just counting by ones. So that's $34.75. So then when we get to making our graph, the things that we need in a graph, we need a title, variables, scale, and then once you have those things, then you can plot the points. And then we need to decide if we need to connect dots or not. So let's go ahead and make a title. I'm going to say that this is called the T-shirt cost for ocean history or ocean bike tours. And a good title will always have the variables in it, and the variables are listed right here. Here's a variable, and here's a variable. So whatever variable is listed first is going to be your independent variable, and that always goes on the x-axis. So we know that the number of shirts must go here, and the cost must go on the y-axis. And it is possible to buy 0 shirts for $0, so we're going to start at 0, 0. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that means I can skip a line. 1, skip 2, 3, 4, 5, 6. Now it's important that each line is worth the exact same amount along an axis. So in this case, every line is worth half a shirt. I know that doesn't make sense, but each line is worth half a shirt. So every 2 lines is worth 1 shirt, and I have to remain consistent all the time. Same has to be true for the scale of the y-axis. So it's probably going to make sense to count by 7s, because the shirt is almost $7. So we're going to go 7. That would make this 14, because each line has to be worth the same. 21, 28, 35, 42, 49, 56, 63, and finally $70. So then we have our scale, we have our title, we have our variables, and so now it's time to plot the points. So our first point is 0, 0, and yes, you have to plot 0, 0. It is part of the data. Then $1 and one shirt for just under $7. Well, if each line is $1, it's going to be almost on that line. It's going to be hard to tell the difference between $7 and $6.95. Same is going to be true here. For $3, 3 shirts, it's just under $21. For 4 shirts, it's going to be just under $28. And your dot should be getting marginally farther away from that line as you go up, because you are not actually spending $7. So then the last question is, should I go ahead and connect the dots? And in this case, the answer would be no, because you cannot sell half of a shirt. In this case, you can sell 1 shirt, but you're probably not going to buy half of a shirt, and thank goodness the belly shirts are no longer in style, so that it's not an option. So if we continue, would it make sense to connecting the points on the line? I've explained why. Because you can't sell half a shirt. Now, obviously, you could connect them and say it shows the pattern better, which is true. But let's stick with mathematical reasons here. C, write a rule using symbols to determine the t-shirt cost for any number of shirts. Well, any number of shirts. Well, remember, we were using S's and C's. S for the number of shirts, and C for the cost. So it asks for the cost for, well, that's just a fancy way of saying equals, any number of shirts. Well, I know the cost isn't equal to the same number of shirts, right? That means that each shirt would be worth $1. Well, what is the cost of the shirts? The cost of the shirts is $6.95. So your equation, or your rule, is going to be C cost is equal to $6.95 times the number of shirts. And you remember that two numbers, or two quantities put together like this, side by side, means multiply. So then, number 2, write a story that would describe this graph. Well, if I look at this graph, I notice that I'm gaining money at a steady rate. And then at this point, I am losing money at a steady rate, but not nearly as fast as I earned it. So there are an infinite number of answers for this one. I'm just going to make one up. Let's say that you are working at the 8th grade carnival, because you will be. But instead of donating the money to continuation, you get to pocket the money. So here, at this point, you are earning your money at a steady rate. At this point right here, this is when you stop working, and instead of working, you decide to start spending your earnings on games. And you play a constant number of games as the time passes until you've lost all of your money, which took a good long time. Again, anything will work for that, as long as it makes sense. All right. The number of hours of daylight in a day changes throughout the year. We say the days are shorter in the winter, longer in the summer. Thank goodness summer is here. Oof. The following table shows the number of daylight hours in Chicago on a typical day in each month. Describe the pattern range month. All right. So I'm looking at the months, and I notice that the time is increasing. And it's increasing at, that's 0.5 hours, no, it's 0.4 hours, increases by 0.2. So I don't really see a pattern in how the time increases, but I notice that it's increasing until we get to a peak. And then from here, June 21st, the amount of sunlight decreases. And again, it doesn't decrease in a steady rate. Next page. All right, D bought a compact disc player with money that he earned working on his vacation. He checked with some stores, find the cheapest, blah, 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 blah. We have Taylor's and we have a buyer's warehouse. And we don't, of course, we do not have a grid. All right, so make a table for the cost of any number of CDs for each store. So we're going to have two tables, or really just one table that's combined. So I'm going to have CDs. I'm going to have Taylor's department store. And I'm going to have buyer's warehouse. And how many CDs will we start off with? Well, we're going to start with 0. And let's, I don't know, let's count by ones. Well, let's see, $25. It's $3. It has a $3 difference. So 3 times 8. Well, we're going to have to go fairly far if we count by, you know what, I'm not going to count by ones because that's going to be huge. I'm going to count by 2s. And how did I know I should count by 2s? Well, I need to see where the lines cross. Where does Taylor's become more expensive than the buyer's warehouse? Because I notice that the department store costs more for each CD, but I don't have a membership charge, right? So that means if I buy 0 CDs at the Taylor's department store, I spend $0. But at the buyer's warehouse for 0 CDs, I had to pay $25 just to get in the door. So if I buy 2 CDs, well, 2 CDs at Taylor's department store is going to be essentially $15.50. 2 of those is $30, and it's almost $31, right? And 98 cents. Whereas here, it's 2 times 12, which is 24, plus my 25. So I'm going to have to continue, and I'm just going to continue with the department store first. So we have the 49 times 2, because I'm counting by 2s. And so then I'm going to add another 2 CDs. Oh my goodness. There we go. So 4 CDs is $61.96. Add 2 more CDs. And we'll do 2 more rounds, right? So this is going to be $154.90. Because I just multiplied by 10, right? And so for 8 CDs, I'm going to add my $30.49. So that's $123.43. I wonder if, oh, no. Sorry, that's 96. Oh, shoot, no, because it's 2 cents less, so it's 92. There you go, 92. All right. For the Buyers Club, we're at $49 plus 2 more CDs, $12 each, so that's $73. Now $73 is still more expensive than that one, so I have to continue. So plus another $24. So I get 97, which is still more. So plus another $24. Ah, look at this. So now the Buyer's Warehouse is cheaper after 8 CDs. So I'm going to go ahead and finish up my table. And so now I know that, you know, anything 8 or more CDs, I should buy Buyer's Warehouse. Anything less than that, I should go to the department store. So write a rule. So again, cost is equal to the number of CDs. And the cost for the tailors is $15.49. Whereas for the Buyers Club, the cost was equal to that $12 I had to, or sorry, that $25 I spent up front plus $12 per CD. So how many CDs would we have to purchase from the Buyers Club for to be the best place to buy CDs? Well, it's obviously 8 CDs, because that's when it becomes cheaper. All right. How many CDs would D have to purchase to have Taylor's department store? So in other words, anything when the CDs are greater than 7, then the buyer's warehouse is best. But when the number of CDs is less than 7, then Taylor's department store is best. Okay, I will do the rest on another video.